Okay, right now we're going to talk about raising I to a power. And we'll kind of go through this, and you'll notice that a pattern develops as we go through it. So if we have I right here, I is equal to I. Okay, now I squared, well, I squared is the same thing as the square root, let's do that maybe in a different color, it's the same thing as the square root of negative 1 times the square root of negative 1. And so our I squared is going to be negative 1. When you multiply two square roots, we lose the square root, and we keep what's in the inside the radical. Okay, so negative 1. Now let's look at another one here. We've got I cubed. Well, I cubed, using our rules of exponents, is the same thing as I squared times I. Okay, so we know that I squared from this previous one, I squared is negative 1. So now it's negative 1 times I. Well, that would yield us negative I. Okay, now let's look at I to the fourth. Well, I to the fourth, if we use our rules of exponents again, it's basically an I squared times I squared. And let's see here, we're using, going back up here, we know I squared is a negative 1. So we're going to take this one right now. That is negative 1 times, and this one's a negative 1 as well. Negative 1 times negative 1 gives us a positive 1. Okay, so I to the fourth is 1. Well, let's go on to the next one. Let's do some more here. We're going to start to develop a pattern. I to the fifth, and again using our rules of exponents here, is the same thing as I to the fourth times I. Well, we know that from our previous one here, I to the fourth is just plain old 1. So basically this is 1 times I. Well, 1 times I is I. Okay. Now we'll go on to the next one. We've got I to the sixth. And I to the sixth is the same thing as I to the fourth times I squared. And I to the fourth we know is 1. That's going to be a key component here, all the ones that we're going to do. So now we've got 1 times I squared. And we look over here, I squared is negative 1. So 1 times negative 1 would yield us an answer of negative 1. And let's go down to I to the seventh. I to the seventh, well, that's the same thing as I to the fourth times I to the third. I to the fourth we know is 1. That's going to be the key here. I to the fourth is 1, then we have 3 left over. So let's see, we're going to have 1 here times I cubed, and I cubed is negative I. So 1 times negative I is going to yield us negative I. And if we go I to the eighth, that's I to the fourth times I to the fourth, which equals 1. 1 times 1 equals 1. And if we continue on, this same pattern occurs. So we're going to have I to the ninth would be I. I to the 10th would be negative 1. I to the 11th would be negative I. Now let's jump ahead just a little bit here. And what if we had a large number? Let's say that we had let's say I to the 502. I to the 502nd power, and that seems like quite a bit. We don't want to sit here and do all of each step all the way till we get to 500. It'd take us too long. But we know from our rules of exponents that this is the same thing as I to the 500 times I squared. Well, we look at this, I to the 500 is a multiple of 4. Okay, this is the same thing as, if we wanted to write it out, we could. It would be I to the fourth times I to the fourth times I to the fourth. We would continue to do that 125 times, okay? And we keep going all the way down. And we'd end up with times I squared. Well, remember that I to the fourth is 1. So all of this is 1 times I squared. We look back up here, I squared is our -1. So the answer to that one would be -1. There's this recurring pattern. So basically, when you get a problem like this, you want to be able to divide it by 4, essentially. And if we take a look at this one, we divide this one by 4, we have a remainder of 2. Whatever that remainder is, we can use this this setup, this pattern right here, and see, okay, remainder of 2, this is I squared, that's -1. If we had a remainder of 3, it would be -I. If we had a remainder of 4, well, that would just be 1. And if we had a remainder of 1, it would be I.